right, let's do another problem, and we'll choose, you can choose a method of your choice, and I'll do the same. So if we have the following example, suppose we have p minus p plus 2 over 4 divided by 3/4 minus 5 over 2p. Because I've used it more often, and so I feel pretty comfortable with it, but either one of the two methods is the same. So I'll use method 1. So by using method 1 again, what we want to do is we want to express, the goal is to express the numerator as a simple rational expression, the denominator as a simple rational expression, and then invert and multiply. All right, so we need to find the common denominator for the numerator. P, just as with the example before, can be written as p over 1, and so the common denominator means if I multiply then the 4, then I have 4p over 4. I've rewritten that number as a number with a denominator of 4. Now for the second term right here, we already have the common denominator there, so we don't need to rewrite it. But the one thing that you need to be really careful with, that can lead to more problems for students. So if you write the negative but then use a parenthesis on the expression p plus 2, sometimes it's tempting to do that, and I encourage you, unless you're really sure of what you're doing, take your time and take some intermediary steps, such as the one that I just used right here. Times 2, and so we're going to have a 2 times 2 times p as our common denominator for the denominator. The first expression already has a 4, but it doesn't have a p, so let's go ahead and write, multiply the numerator and denominator by p over p. That gives us 3p divided by 4p, which is the denominator we want to have. The second term of the denominator, it has a 2p, but we need 4p, so we'll multiply by 2 over 2. Remember not to multiply by too much. We want just the 4p, so all we need to multiply is by 2 over 2. And so now we're going to have a minus 10 over 4p. Okay? Now, we're ready to do invert and multiply, but before we do that, let's simplify the expression in the numerator by carrying that negative through. And so remember, we have a negative, which means that this will become a negative p and a negative 2. So the numerator now is 4p minus 2. And so we end up simply with 3p minus 2 divided by 4 over 3p minus 10. Of writing this as a simple rational expression in the numerator divided by a simple rational expression in the denominator. So now we can invert and multiply. So when we do that, 3p minus 10 divided by 4p, oh, and I rewrote it again the same way I had it before, so I meant to invert and multiply. So, and we will have 3p minus 2 over 4 times 4p over 3p minus 10. Okay, now we can case are the 4s, because all of the other factors are within the parentheses in the other factors, and so we can't do anything with those. So finally then, for this particular problem, the answer is going to be p times the quantity 3p minus 2 divided by 3p minus 10. Now, there's always the question, should you multiply out the numerator and write it in multiplied form? If you need to multiply it later, you can. However, these rational expressions are probably going to be parts of other problems, and you might as well leave it in factor form until the end, because you might need to refactor it again. Parts. So this is as good an answer for that problem as any. And it's a practical answer. Okay? This one will be something that doesn't look like a complex fraction. X to the negative 1 minus y to the negative 1 over x to the negative 2 minus y to the negative 2. Negative exponents. You know what to do with those. So if you first write the exponents as positive exponents, then it might give you a clue as to what you need to do. The y to the negative 1 as 1 over y, and for the denominator, x to the negative 2 is 1 over x squared, y to the negative 2 is 1 over y squared. And you see that what we have right here then has become a complex fraction. So sometimes negative exponents result in complex fractions. To solve this particular complex fraction, to simplify it, let's use method 2 to practice with that method. So remember that in method 2, we're going to be looking for the overall lowest common denominator. Okay? So we're going to need to include the x, and we need to include the y that we have as a denominator in the numerator. But for the denominator, we need an x squared. We've only got 1, so let's put another x factor there. And we need a y squared. We've only got 1 y. Now, rather than working with this, let's work with the expression which is written as a complex fraction. And remember that in method 2, we take that overall lowest common denominator and multiply both the numerator and denominator by that. Once again, we'll use the distributive property, and so that says that we're going to take x squared y squared and multiply it by 1 over x minus 1 over y, and take x squared y squared and multiply that by 1 over x squared minus 1 over y squared. Okay, using then the distributive property, we'll have first rational expression in this expression, 1 over x, minus x squared y squared times the second expression, rational expression. Notice that what we're doing here is we're multiplying this times the first expression and this times the second expression, which is what the distributive property does. Let's do the same thing for the denominator. Minus x squared y squared times the second rational expression. And now we're ready to do what very nicely that method 2 does, and that is to eliminate the first term in the numerator. One x factor disappears from the x squared here, and we're left with a plain xy squared. Factor disappears, and we're left with minus x squared y. For the denominator, the x squareds disappear, and we end up with a plain y squared. And then for the second term, the y squareds disappear. We end up with a plain x squared. Okay? Now, we're almost finished with the problem, but now we do need to, at this point, to simplify. And so we need to factor both numerator and denominator and see if we end up with common. The numerator, we do have an x and a y, which is a common factor. Let's factor that out. We factor the x out and the y from. For the second expression, if we factor an x from the x squared, we'll be left with the x, and the y is all factored out. So we have xy times y minus x. Let's check that out. xy times y is the xy squared, and the xy times the negative x is the x squared y. Let's do the same thing in terms of factoring for the denominator. And remember that in factoring, look for the common factor. See if the expression can be factored at all. And right over here, you notice that we have a difference of 2 squares, and we know that that can be factored. Number plus the second number, right? Those are the factors of a difference of 2 squares. Well, at this point then, luckily enough, we do have a common factor, y minus x. We can cancel that out, and finally we've got our expression simplified, which is xy over y plus x. All right, you ready to go with complex fractions? And so good luck.